Welcome to the unit on key terminologies. In this unit, you will review key terms and definition of apparel manufacturing industry. The final review section invites you to reflect on what you have learned. By the end of this unit, students will be able to understand the key terminologies used in apparel manufacturing, develop suitable methods of managing WIP efficiently, recall ways to make a capacity study. Let's move to key terminologies, whatever we are using in garment manufacturing. So, the different key terminologies are there in apparel manufacturing or garment manufacturing. Those key terminologies will keep coming, and these terminologies will be useful in later half. We'll discuss about these terminologies on our later units also. So, we will start our discussion with the term of production and productivity. The two terms are there. This is the production and productivity. So, what is production? Production is nothing as the output. What we are producing. We can talk about the output. Output can be if you talk about the garment. In the garment, output are in pieces. So, we are producing, suppose a factory is producing 1000 pieces. So, per day the production is 1000 pieces. So, we can say the output is 1000 pieces, that is the production. So, production of factory, we are having the 1000 pieces. Okay. Now, what is productivity? The productivity is a relative term. Productivity is a relative term. Productivity is basically the ratio of output to input. So, it is normally represented as output divided by input. So, this is the productivity. Now, output is, we have discussed our production is nothing is output. So, how many pieces we are producing, that is the output. Now, what is the input? The moment we talk about the input, input refers to all resources what has been used in producing the output. So, what are the resources we are using? The resources input can be, the examples of input can be man, it can be machine, it can be material, and so on. So, we have the input and we have the output. So, input can be man, machine, material. So, as this discussed, this is the relative term, and relative term we will talk about. I will explain with the example to make it more clear that how we can, what is the difference, exact difference between production and productivity. And second thing is that production, whether the production is increasing, a factory production has increased from certain amount to certain amount, whether the productivity will also increase. Production and productivity synonyms. So, these things we will discuss. Definitely by looking the picture, looking the formula, we can say that production and productivity are not synonyms, because productivity is the ratio of output to input, and production is simple output. So, we will take an example like the suppose production of a factory, or factory is producing 1000 pieces in a day, per day. Okay, so daily production of a factory is 1000 pieces. Now, we have to calculate the productivity of the factory. Productivity of the factory in terms of productivity per machine. Per machine productivity we want to calculate. So, 1000 pieces is the production. Now, how many machines we are using for producing of 1000 pieces? Take example of we are using 250 machines. 250 machines we are using for producing 1000 pieces. So the productivity per machine is 4 pieces per machine. This is the productivity of the 1000 pieces whatever we are producing. So take example, this is the case 1. Now case 2, we talk about the case 2. In case 2, the production has increased from 1000 to 2000 pieces. Now we have taken the bigger facility, and in that particular bigger facility, output has increased from 1000 pieces to 2000 pieces. So now production has increased from 1000 pieces to 2000 pieces, mean production has increased by just it become double. So now we will check that whether the productivity is also increased in the same rate or not, or productivity has increased or not, simple term. So now we talk about the productivity. Again we are taking the example of input as a machine itself. So output, formula is output divided by input. So output has increased, now new output is 2000 pieces, and we are using more machines now. In the place of 2050 machines, earlier we are using the 2050 machines. Suppose we are using the maybe we are using the 800 machines for the production of 2000 pieces. So whether my productivity has also increased, because we have seen the production has increased from 1000 to 2000. Now productivity has increased or not? Because my production has increased from 1000 to 2000, my machine in the input has increased from 250 to 800. This is the machine. So now my production will be 5 pieces per machine. So we can simply say that earlier my productivity was, sorry, it's not 5 pieces, it's 2.5 pieces. So it's 2.5 pieces per machine. So earlier my productivity was 4 pieces per machine. Now my productivity has decreased from 4 pieces to 2.5 pieces. So we can simply say here by this example of 2 examples, like first case the production was, output was 1000 pieces, and productivity per machine was 1000 piece, that is output divided by input, 1000 by 250 machines we are using. So it is 4 pieces per machine. Now in the second case, production has increased and production has become 2000 pieces. The productivity, the formula is output by input. 2000 pieces was the output, and now number of machines what we are using is 800 machines. So 2000 divided by 800, 2.5 pieces per machine. So ultimately the productivity of, although the production has increased, the factory production has increased, but productivity has decreased from 4 pieces per machine to 2.5 pieces per machine. So this is the example where we can understand that always production and productivity, if there is increase in the production, it doesn't mean the productivity will also increase. Productivity may decrease. It depends on that, about the resources. What is the input? How much input we have used? If we have taken the more inputs, more resources, then definitely productivity will decrease. If we are taking the less resources and we are producing more, then definitely productivity will increase. Now we will discuss, after this, we will discuss the another term, which is very important term, that is known as clock time, on standard time, off standard time. So I will just discuss about these two terms. The terms are, first term is known as clock. Next we are talking about the terms which is known as clock time, on standard time, and off standard time. So these are the three terms are there, which is basically used to understand the complete time of operator's time, to gauge the how many minutes or how many hours operator was there, how many hours he was doing the productive pieces, who are doing the productive work, the person was doing the unproductive work. So first we will discuss about what is the clock time. The clock time, the time available to an operator for doing work during the day. It does not include lunch time. So clock time is basically how much time, that's called available time. Available time minus break time. If any break is there, then break time will be taken off. So what is available time? We take example of an operator comes inside the factory in the morning 9 o'clock, and he leaves factory at 5:30 p.m. in p.m. So evening he is leaving, he is coming in the morning 9 a.m. and he is leaving at 5:30 p.m. So total time he is there inside the factory is from 9 a.m. till 5:30 p.m. he is there inside the factory. The total time is 540 minutes. That is 8.5 hours. So he is there inside the factory 8 hours 30 minutes. 8 hours, and he is there inside the factory 30 minutes. So total 8 hours and 30 minutes he is inside the factory. So out of 8 hours 30 minutes, he is having the lunch break at 1 p.m. to 1:30 p.m. So he is having the lunch break from 1 p.m. to 1:30 p.m. So lunch break time is 30 minutes. So 30 minutes is the lunch break time. Now out of this 540 minutes, 30 minutes is the lunch break time. So total available time is from 9 a.m. to 5:30 p.m. minus break time is 30 minutes. So 540 minus 30 is 480. So the clock time of the operator is 480 minutes. That is 8 hours. Although operator is there inside the factory for 8.5 hours, but lunch break is there for half an hour time. So lunch break will not, or any break time will not be calculated in this particular case. So clock time of the operator, for the time he is being paid, he will be paid for, not for the 8.5 hours time, he will be paid for 8 hours time. So in 8 hours of the time, operator will be there. So 8.5 hours of the time, he will be paid, out of 8.5 hours of the time, he will be paid for 8 hours, excluding the lunch break. So that is 480 minutes. So 480 minutes is the clock time. Now after clock time, we will understand about what is the on-standard time, what is the off-standard time. The off-standard time is basically the time during which an operator is unable to do some work due to factors which are not under his control. Those factors are the time span during which the productive work is not done. No productive work is done. The examples of those the factors are power failure, machine breakdown, or doing repairs for someone else. So it can be the off-standard. The moment we talk about the off-standard time, so off-standard time when no productive work has been done. So if the no productive work has been done, so that time comes under the off-standard time. So no productive work has been done. Examples can be, we have the machine breakdown, there is no power, no feeding was there, no cut parts were available, he was ready to work on, but he was not having any job to do. So it's a management problem. So mean to say that machine breakdown is there, no power is there, no feeding is there. These all are the problem which is not due to, it happened due to the operator's mistake. Because operator is available inside the factory, he is ready to do the job, but a management, a supervisor, the line manager, production manager has not given the job to him. The allocation of the job was not given to him. So he should not be penalized. He is there inside the factory. He is ready to do the job. So this is the problem. External factor like the machine breakdown is there. Some major machine breakdown is there. Maybe reason is that maintenance was not proper for that particular machine. Prevention was not done properly. Maybe there is no power. Power is not there. Genset is not working, or there some problems are there which is not under the control of operator. No feeding is there. No feeding means there is no cut parts there. The pieces are not available to the operators so that he can do his or her operation. So that these are the examples of where we can say that the obstinate time. So obstinate times can be reason can be due to these different. These are the external factors. So when there is unproductive time is there, so that time comes under the obstinate time. So now we will talk about then what is the equation all about. What is the relation between the obstinate time, clock time, obstinate time? So we will discuss here the moment we talk about the now what is the relation between clock time, obstinate time, obstinate time. So now clock time is equal to obstinate time plus of standard time. So when obstinate time is the time which is unproductive time, and obstinate time is the time made available to the operator for producing productive work. It can also be defined as the difference between the clock time and obstinate time. So thus we can say that clock time is equal to obstinate time and obstinate time. So obstinate time is the productive time and obstinate time is the unproductive time. So taking all the times into consideration together, it comes under the head of clock time. So we will take one example to understand it better. How much clock time will be there, how much obstinate time will be there, how much obstinate time will be there. So we take example of Rohan as an operator, as a sewing operator. He comes inside the factory at 8:30 a.m. and he leaves factory at 5 p.m. Now he is coming inside the factory at 8:30 a.m. He leaves the factory at 5 p.m. and the which is assigned a lunch break. Lunch break is basically from 12:30 p.m. to 1 p.m. So that is of 30 minutes lunch break is there. Now what happened? There is a machine breakdown. Machine breakdown is between machine breakdown starts at 11 a.m. till 11:30 p.m. Half an hour is the machine breakdown. And then there is no power from 12 p.m. till 1 p.m. So to calculate what is the clock time on a standard time and off standard time. What is this? On standard, off standard, and clock time. So this we have to calculate. So the examples is very clear. Rohan comes inside the factory at 8:30 a.m. He leaves the factory at 5 p.m. Lunch break is, the factory lunch break time is 12:30 p.m. to 1 p.m. That is for 30 minutes. Machine breakdown time is from 11 a.m. to 11:30 p.m. Sorry, 11 a.m. to 11:30 a.m. and no power is there from 12 p.m. to 1 p.m. So now we have to calculate the clock time, we have to calculate the on standard time, and we have to calculate the off standard time. So now we will do the calculation here. We will try to understand the calculation, how much. So we will see that what is the clock time. First is the clock time. Clock time is 8:30 a.m. minus 5 p.m. Its total is 5:40 minutes. That is 8.5 hours time. He is inside the factory, and lunch break time is 30 minutes. So again here also his clock time is 480 minutes. That is the 8:30 minutes minus 30 minutes is 8 hours. 8 hours is 480 minutes. So 480 minutes is the clock time. Now we will calculate the first off standard time. Off standard time is basically the time where the unproductive work has been done. So machine breakdown is of 30 minutes and no power is from 12 a.m. to 1 p.m. So that is of 60 minutes. So 30 and 60 minutes, but we have to be very sure about that there is an overlap. From 12 p.m. to 1 p.m. there is no power, but 12:30 p.m. till 1 p.m. there is a lunch break. So lunch break time there is no power, that's not a problem. The problem is 12 p.m. to 12:30 p.m. So this 60 minutes, in the 60 minutes we will have only 30 minutes comes under the off standard time for due to no power. So 30 minutes will be the time when there is no power. So off standard time in this particular case, I will rub the up top part. So the moment we talk about the off standard time is 30 minutes for machine breakdown and another 30 minutes. It's not 60 minutes, kindly take care. That is 12 p.m. till 12:30 p.m. only has been taken as a no power. So 30 plus 30 is 60 minutes. So there is no power for there is off standard time for 60 minutes. So now we will calculate the on standard time. So on standard time is clock time minus off standard time. Clock time is 480 minutes minus off standard time is 60 minutes. So this will give the 420 minutes is the on standard time. Off standard time is 60 minutes and clock time is 480 minutes. So this is the example which explains about the clock time, on standard time and off standard time. So the examples, if you talk about what are the other examples are there for off standard time, the examples of off standard time is basically the time that time operator spends on unmeasured work or measured work, that is classified as off standard time. The examples of those measured and unmeasured works are the time should be reported on the labor cost control sheet, waiting for the work, machine breakdown, unmeasured work, that is the operation not yet allocated, that is the another issue, sampling, repairs, paid average for balancing, under retraining, indirect work, covering for supervisor. These all things comes under the obstinate time. Okay, apart from this what we discuss. Now we are going to discuss the very important two more very important terms, which is known as SAM and what is SMV. Basically, the moment we talk about the SAM, SAM stands for Standard Allowed Minutes. The moment we talk about the SMB stands for Standard Minute Value. So whether there is any next question comes, where there is correlation between SAM and SMB. There is any relation between SAM and SMB? So we'll discuss first we'll discuss what is SAM exactly. The full form of the SAM is Standard Allowed Minute. It is also means time in minutes that is assigned to a specific operation after doing the time study or using PMTS, that is a predetermined motion time systems. So different data we are taking, either from the time study, we are doing the time study, and time study we are finalizing, we are taking the data, that is some standard data we are getting, that's known as a SAM. So that is the standard allowance also means time in minutes. So for any specified operations where we are taking the data. Now SMB, as I discussed, the SMB full form of SMB is standard minute value. Standard minute value means the cost factor in cost per minute, that is multiplied with SAM to get the cost of the operation. So this is the SAM and SMB. We'll first discuss about the SAM, how to find out the SAM, and then we'll discuss about the relation between SAM and SMB. So the calculating SMB and SAM. So SAM or SMB is generally calculated as observed time, that is observed time which we can take in the time study, plus rating allowances, plus P and FD. P and F stands for personal fatigue and delay allowances, and then synthetic time. This is the way the SAM or SMB used to calculate it. When SAM is used as an extension of SMB, that is, it is allocated time for a task rather than the measured time. So now we will discuss what is the relation between SAM and SMB. SAM is equal to SMB. So the moment we talk about the SAM and SMB, relation between SAM and SMB, SAM is equal to SMB plus policy allowances. SAM is equal to SMB plus policy allowance. The policy allowance depends on the management, how much allowances they want to give for in that particular case. But at any case, the policy allowance should not be more than 5%. So the SAM and SMB can be equal if the policy allowance is 0. If the policy allowance is 0, then SAM and SMB will be same. After clock time, on-standard time and off-standard time, the two key terminologies are also very, very important, which is known as SAM and SMB. Two terms, we'll discuss about the SAM, and another term is SMV. SAM stands for Standard Allowed Minute, and SMB stands for Single Minute Value. So SAM and SMB both are used to set a target for each and every operations. The SAM is basically the time in minutes that is assigned to a specific operation after doing time study or using PMTS, that is predetermined motion time system data. So whatever the way how we are going to use the SAM, value of the SAM. Take example of operation like collar run stitch in a shirt. To collar run stitch in a shirt, the SMB or we take the first example of SAM. SAM of collar run stitch operation is 0.5 minute. So 0.5 minute is the SAM of collar run stitch operation. So 0.5 is the SAM of collar run stitch operation. Now we have to set a target for an operator who is doing the collar run stitch operation. So collar run stitch operation the operator is doing. So 0.5 minute is the SAM. So 0.5 in a minute his target should be 2 pieces. So in an hour his target should be, so basically he has having the time of, if he is inside the factory for 480 minutes, 480 minutes is the clock time for the operator. So the target for that particular operation for that particular operator is 960 pieces. So 960 pieces is the target for that particular operation, best for that particular operator on that particular operation, based on the SAM value of 0.5 minute. So 0.5 is the SAM for that particular operation. So target we are going to set. The same we are doing for the SMB also. SMB is nothing, is the cost factor in cost per minute that is multiplied by SAM to get the cost of the operation. So we will understand SAM and SMB, and then we will have the calculation for that. So the SAM or SMB is generally calculated as observed time. That is the time in the time study. We will have the observed time. We'll just write down the what is the meaning of this one. So we'll talk about the SAM SMV. What is the formula? The moment we talk about the SAM or SMB, this is basically the observed time. What is the observed time? What we are getting in the time study. So this is basically about the observed time, plus we are having the rating allowances, and then we are going to add PNFD allowance. PNFD stands for persons, fatigue and delay allowances, is known as allowances. And we also add synthetic datas. That is the synthetic time. We can say that we are using the synthetic time here. This is the formula of SAM and SMB. This is the way SAM and SMB calculation happens. When SAM is used as an extension of to SMB, that is, it is allocated time for a task rather than measured time also. So the relation between SAM and SMB, once we talk about the relation between the SAM and SMB, the relation between SAM and SMB is SAM is equal to SMB plus policy allowance. We'll discuss this in detail. What is the policy allowance? What is the, how it has been added? But here I just want to say you that policy allowance is decided by the management, that how much we are going to on top of SMB, how much policy allowance a factory wants to give in terms of to ease the target of the operator. But at any cost, the policy allowance should not exceed more than, it's a minimal. So if the policy allowance is 0, then the SAM and SMB will same. If the policy allowance is 2%, the SAM and SMB has a difference is only 2%. So that is the minimal allowance we are giving in the policy allowance, and that is decided by the management of the company. So next, we after this SAM and SMB, we talk about the different type of the allowances what we are giving. So we are having the different type of the allowances. What we have mentioned that we have the rating allowance, we have a PF&D allowance, and we are having the machine delay allowance also. So what are the different type of the allowances are there? Why we are giving the different type of the allowances? So different type of the allowances can be machine allowance, P, F and D allowance, and definitely we are giving the rating factor also in this rating factor. So, and if in the case of the progressive bundle unit system, we are having the bundle system, then we are giving the BST allowance also. BST stands for bundle handling time. So BST allowance also will be given in this. So now we will after this we will discuss about the what is the machine delay allowance. Machine delay allowance, what are the factors are there which includes in the machine delay allowance? What are the factors are there which is includes in the PNFA allowance? What are the factors are there in the includes in the rating and BST? So machine delay allowance, if we talk about the machine delay, that's also known as MD allowance. So machine delay allowance are the allowances which we are giving for the thread breakage, against the thread breakage or thread changes, because the bobbin, if we are using the major operations are being done in the most common machine, that is a single lock stitch machine, where the bobbin and needle threads are there. So bobbin changes has to be done. So bobbin changes has to be done in the lock stitch machine, and thread changes normally happens in lock stitch as well as other machines also, whether we talk about the overlock, whether we talk about flat lock, whether we talk about the buttonhole. So all the machines, almost all the machines, we are having the thread changes. Then cleaning and oiling machine, the allowances we are also giving for the cleaning and oiling of the machine. So apart from the cleaning, oiling, we talk about the thread changes, we talk about bobbin changes, we are having the needle breaks. What is the minor needle breaks happens? If in the case of the needle break, needle change has to be done. So these are basically the allowances are there which comes under the machine delay allowances. Okay. Even first 15 minutes of the machine delay, if any delay happened due to these things, so for first 15 minutes we are considering as a machine delay allowance. After that it comes under the machine breakdown. So machine delay allowances factor is applied to total cycle time. This has the effect of giving a delay allowances on multi manipulative elements within a machine cycle, such as pickup garment. On an average, this does not present a problem since percentage has been developed from actual experience. However, a job with an unusual high or low percentage of pure work in the cycle would merit a discriminatory adjustment to the factor, and the engineer is expected to be alert for this. So, in this particular machine delay allowance. Now, after the machine delay allowance, next allowance is called as personal and fatigue allowances. Next allowance is personal fatigue allowance. Personal and fatigue allowance are given to the operators because they have the people needs to have the some type of relaxation. Even if the person is doing the work for in a stretch of 4 hours or 8 hours of time, he needs some type of the breaks, some types of the break in terms of he needs a break for to go to washroom, he needs a break to drink water, he needs a break to stand or sit or do small exercise, then again start working on the operations. So these are the breaks what we are giving to the operators. These are the parts of personal fatigue allowances. So even the operators are doing the standing operation, he needs different type of the allowances, different percentage of the allowances. Person are doing the sitting operation, he requires that another type of the allowances. So maybe a standing operation, the pressure is more, the allowances is given which is more, and for sitting operation we are giving the comparable lesser allowances than the standing operation. Next, we are going to talk about the what are the things are there which is there in the personal fatigue delay. As I discussed about the personal fatigue delay allowance we are giving, that is the break, sometimes the break, small breaks if the operators are taking, that is the part of that. For personal needs, we discuss about the for the restroom, person wants to go to drink water, some conversations, minor conversation he wants to do with the colleague or friend, that can be given there. The factors for loss of the pace due to getting tired, if the persons are getting tired, so the speed can be less in during that particular time. So those are has been covered in this person fatigue delay allowance. Okay. So after this, we will discuss about some more terms that comes under the term of efficiency. We talk about the efficiency. What is efficiency all about? Efficiency, the moment we talk about the efficiency, it is a measure of how well section or factory runs. The moment we talk about the efficiency, efficiency is a measure of how well the section or factory is running. It is a measure of both operator and the supervisor. It incorporates elements of operator performance and utilization into the single measure. So, in the efficiency, the formula of the efficiency is basically efficiency we try to find out for a section or a group or a line. So if we talk about the efficiency, how to find out the efficiency, that is very, very important. To understand the efficiency, formula for efficiency is basically SAM into output. That is SAM into output is also known as SAM produced. Divided by this one, divided by into manpower, and the whole will be multiplied by 100. So this is basically the formula of efficiency. So SAM, we'll discuss about the SAM, how to calculate the SAM. Then output, how many pieces you have made that day during that particular period of time. The period of time is your clock time. Like clock time is 8 hours. Then in 8 hours of the time, how many pieces you have made, that is the output. What was the SAM of that particular operation? We can take the SAM and we'll further divide by manpower, and everything will be multiplied by 100. That is the efficiency percentage. We talk about the efficiency percentage. We take an example of this efficiency. Like the SAM, the same example we can take where we have taken the earlier the SAM of the one operation, that is we are the collar run stitch. Collar run stitch SAM we have taken as 0.5. Okay. And suppose the operator who is doing the collar run stitch, he is making 480 pieces per day. He had made 480 pieces on that particular day. And the clock time is 480 minutes. And we talk about the manpower. Manpower in that case, one operator has made the garment, made that one. So 1. So in this case, and we will multiply everything by 100. So in this case, this will be 0.5 into 100 is 50%. So his efficiency is 50% in this formula, where we talk about the clock time. Another factor we will also talk about, that is called performance. If you talk about the performance, how to find out the performance? So here we have taken the clock time. Just take into consideration that here you have taken the clock time, and the moment we talk about the another formula is basically the performance. So performance formula, if you talk about the what is the performance? Performance is basically SAM into output divided by, in the clock time, it's basically the on standard time. And once we talk about the performance we talk about the individual performance, like the operator performance. So how many pieces that operator is going to make, that is called performance. And efficiency, we talk about the group. We talk about the efficiency of a group, we talk about the efficiency of a section. So whenever we talk about the individual, we normally take the on standard time. Because why we are not taking the clock time? Because clock time will have inclusive of off standard time also. So we talk about the performance of an operator, performance of an individual. So if you talk about the performance of the operator, we should always calculate in terms of the on standard time, the time which is basically assigned to him for the job, the time the operator has done the job, the time where the machine breakdown was there, the time when there's no electricity was there, there's the time where there's no feeding was there. Why to calculate the performance? Why to gauge the operator's performance on that particular parameters? We should only gauge the individual performance on in terms of on standard time. As this is the individual thing, so if you will multiply by the manpower also, it will become 1 only. So no need to multiply by the manpower. So performance formula is SAM into output divided by on standard time. And efficiency formula is basically, and efficiency, once we talk about the efficiency, mainly we are calculating the efficiency for groups or sections. In group or section, what happened? We are talking about the SAM into output. These are the common in both the things. And then we are talking about the clock time. Clock time is inclusive of on standard time and off standard time. Off standard time is the unproductive time, where basically the breaks or some management, due to some management issues, the work has not happened. So work has not happened during that particular time. That is also the management, because we talk about the group or section where individual is not responsible, where the whole group is responsible, including the management also. So we talk in terms of the efficiency, where we are taking the management also, accountable. And the moment we talk about the performance, that is individual, where management is not accountable. So we are taking the clock time here. Clock time means maybe the here on standard time is 50% only, but 50% time is off standard time. So definitely the efficiency will be less. So but that has to be also, so maybe we can say that the individual performance of the operator is 100%, but efficiency is 50% only. That is also possible, because out of 8 hours time, sometime it is also possible that on standard time is only of 4 hours. 4 hours was off standard time, where there is no power. Suppose no power was there for 4 hours. But here, once we divide with the clock time with the 8 hours, and here we we have the on-stand time as 4 hours only. The target for here will be made based on the performance. Here the target is made based on the 8 hours of the clock time. So definitely we the management can always check that the performance is 100%, but the individual performance of the in the that particular line, everybody's individual performance is 100%. But maybe the case that although the individual performance is 100%, in the efficiency of that particular line is only 50%. So where is the problem? Problem happens due to some reasons. What are the reasons? Which is not under the control of the operator, which is the maybe the some problem which is related to management. What we discussed, like all the optional times are related to the management. So these things can be easily, management can do the comparison. Management can see that what is the efficiency, what is the performance, why it is happening, what is the problem, whether it's the operator driven problem, whether it's the management driven problem, and wherever the problem is there, the root cause analysis can be done for that particular thing, and it's easier for the management to find out the reasons, okay, and do the analysis for that. After SAM, efficiency and performance, next thing we are going to talk about the capacity study. The capacity study, when we make a capacity study on an operator, we are measuring the performance. She should attend if she continues to work at the same pace and use the same method as observed during the study. This means that at the end of the study, we can say that operator has the capacity to be 120% performer, or whatever performance level the study indicates. Capacity means the same as a capability. It means that the operator is capable of achieving the performance measured by the study. So just we'll take example of the capacity study. Capacity of a person. We take example like from eating habit only. Capacity of a person to eat, maybe he can able to eat once in a blue moon. If given that favorite food, he will able to eat maybe 10 chapatis. But it's not possible that every day he will able to eat 10 chapatis. He will be, on average, he will be eating 5 chapatis. But his capacity is that he can eat 10 chapatis also. That is the capacity. So we are doing the capacity study. This is the performance of that particular person who can go on this is the capability. We talk about the capability of that particular person. So that is the basically which has been discussed in the capacity study. So now next is basically we talk about after the capacity study we talk about the rating. The next is after capacity study, this is the rating. Rating factor we have discussed, and in the SAM. Once we are talking the SAM, we are talking about the different allowances are there. That is the machine delay allowance was there. Machine delay allowance. Then we talk about the persons P and F, PF and D allowance, and then we talk about the rating. So different allowances we talk about and here the rating is a factor which basically used during the time study. If you are doing the time study, the rating factor has to be taken care of. The rating corresponds to the average rate at which an operator will naturally work at a job, provided they know adhere to the specified method and provided they are motivated to apply themselves to their work. So British standard provides 0 to 100 scale for rating. Here 0 represents no work at all and 100 is the normal rate. We rate the job on the scale after observing the operator. A slow rate may be rated around 50 and a fast rate may be rated around 125 or 150. So it depends on the how fast, how slow the operator or operation is. So we can define rating is the uh, that concept of the rating, which is known in the US as a grading also, is a fundamental in time study. The ability to rate effectively distinguishes a qualified time study practitioner from a novice. So rating, we can also say that rating is a process used by the industrial engineer to compare the actual performance of the operator which with his or her mental concept of, and we have taken the time study of the operator who is very fast. And now kindly note that we are going to set the standard for that particular operation, standard time for that particular operation. So operator is very fast, he will take less time to complete that particular job. If he is taking the less time to complete the job, as per that operator, if we have set the time. So suppose I have set the time as per that particular operator, that time will be difficult to achieve by any average or normal operator, because the target will be set based on the time, because that operator whom we have taken the time study, he was very fast, so the time he took is very less time he has taken. So say like in the average operator is taking 0.5 minute time and he was taking only 0.35 minutes of time. So as he is taking 0.35 minutes of time, the number of pieces, the target will be more than the, if the operator is taking the more time. If operator is taking more time, the target will be set, standard will be set based on the more time. So that's why we are neutralizing the factor by using the concept of rating, the speed factor by using the concept of rating, so that by the rating, if you're using the rating, then everybody, the standard, once we talk about the standard will be for everybody. If the slow operator is there, he is taking more time, then we will multiply by, maybe suppose slow operator is having the 50% of rating. So I just take example and to make it more clear about the rating. Rating here, if a slow operator is slow, he is taking, his rating is only 50%, and the operator having the is a very fast operator, his rating is 150%. So slow operator, if you have taken a time study, we found that this slow operator is taking maybe 60, is taking maybe 1 minute to complete any particular job, and the the fast operator is taking 0.33 minutes to complete the same job. So the job has given to the slow operator, the same job has given to the fast operator. He is taking 1 minute of the time to complete the job. The fast operator, who is having 150% of the rating, he is taking 1.33 minutes of the time. So which time I should take as a standard? Which time has to take the standard? We will not take either of this time, because standard time has to be taken considering the operator who is the normal operator, that is the average operator or normal operator. So average operator or normal operator. So suppose I will multiply here. How to take it? So we will multiply here. The concept comes as the basic minute. Basic minute is basically, this is the call single cycle time. I will discuss those things in detail later on. So 1 minute multiplied by 50% is basically 0.5 minute, is basically the time which will come from here. Now here we are having the, in second case, 0.33 minute multiplied by 150. It also gives almost 0.5 minute. So if we will multiply the the reading, whatever the reading we have taken, by the rating factor. Here also we multiply the reading with the rating factor. The result will be the almost the same. 0.5 minute here also, 0.5 minutes also. So we are using this particular tool to basically neutralize the factor of deviation. So we are making it as average as 100%. That is the concept of rating. After rating, after doing SAM, performance, efficiency, rating and capacity, the next important term is utilization. The utilization we talk about is a tool which is used to determine the time percentage during which the operator works in a day. It is represented as utilization is equal to on standard time into, so the utilization is equal to on standard time by clock time, it will be multiplied by 100. So once we talk about the utilization of the operator, so operator, suppose operator has worked inside the factory, he is there, the clock time of that particular operator was maybe 480 minutes. He was there working on the machine for 480 minutes, rest 4 hours he was sitting idle because there is no job and no job has assigned to him. So in this case we will see that utilization is only 50%. So although operator was there inside the factory for complete 8 hours of the time, but we have utilized, the management has utilized only for 4 hours out of 8 hours. So utilization is simply is a 50%. So utilization is on standard time by off standard clock time. So by looking this utilization percentage, a management will take a call that why utilization is less. So these utilization factors are very important as handy tool for management to understand where is the company, where the company is having the problem, why utilization is less. Then further he will go for the root cause analysis. So now after going in detail about these things, we will do the compilation of, we will do the summarize the each and every formula what we have discussed. So first is basically the SAM. So first is basically the SAM. SAM, how to calculate the SAM? SAM, the formula of SAM is basically ASCT. ASCT stands for average single cycle time. So to find out the SAM, first we have to calculate the single cycle time, the whole rotation of the operation. Like operation is having the different elements. Operation, for one operation, suppose we are doing the operation for like we have taken the collar run stitch. Collar run stitch operation, we have to pick two plies of the collar, top and bottom. So picking is required, then we have to do the align, then we have to do the sewing and then dispose. So if you talk about the cycle time, this is the cycle, and which has the components are like, this is the pick, then it's align, then it's sew, and then it's dispose. So picking, then alignment of the parts, then sewing, and then dispose. So in the cycle time, this is the cycle, single cycle time. Accordingly, we will during the time study, industrial engineer has to take around 10 to 15 cycles, and then he has to do the average. He has to find out the average, taking which cycle is execute the taking the cycle average of the cycle, that comes under the ASCT. So ASCT is then after we have discussed already about the rating. So ASCT into rating. This ASCT into rating is also known as, in the place of ASCT into rating, we can write the BM also. BM stands for basic minute. So in the BM, we are going to neutralize the factor of slow or fast operator concept, and then this ASCT into rating will be multiplied by 1 plus MD, that is the machine delay allowance. Then we are going to add the P and FA allowance, P and FA allowance, personal fatigue, P and FD we can also write, P and FD allowance, and this whole will be added with the BHT, that is the bundle handling time. So the formula for, we can see here, the formula for SAM is average single cycle time. Average single cycle time, we have discussed that average single cycle time is the average of the single cycle. So we have taken the 10 readings or 15 readings, taking the whole operation, and then after we are finding out the average, then it will be multiplied by the rating factor, then it will further multiply by 1 plus machine delay allowance. Machine delay allowance is basically we are giving for different operations, we are giving the different machines requires the different machine allowance. It's around 5% or 8% to 10%, depend, like the single log switch machine has different swing allowance. 5% is the single log switch machine, we are giving the machine delay allowance. Double needle log switch machine, we are giving the 8% of the allowance. Then we are giving the P and FD allowance. P and FD allowance is basically nothing, is a allowance given for the operators for doing their recreations or for doing the small jobs like the restroom and toilets and for drinking water and all. So it's varies, like for sitting we are giving around 11%, for standing operations we are giving around 13%. So it varies from the what type the environment is of, and then we are adding, finally we are going to add the BST. BST stands for bundle handling time. After this we have discussed about the clock time. Clock time is, we have discussed, that's the summation of on standard time plus off standard time. So clock time we are not going to add the break time. Break time has been excluded from the clock time. Then we have discussed about the capacity percentage. If you talk about the capacity percentage, to find out the capacity percentage, we are having the formula TSCT. TSCT is target single cycle time. Sometimes you talk about the total single cycle time, is multiplied by 100, and the whole will be divided by ASCT. So this is basically the capacity percentage. Then next is performance. The moment we talk about the performance is basically output into SAM. This output into SAM will be divided by on standard time, and finally it will be multiplied by 100. So we discuss about the, once we talk about the performance basically we are talking about the in terms of percentage. Performance we talk about for the individual. For a direct workers we are talking about the performance, that is individual, we talk about the performance. Then next is, if you talk about the efficiency we talk about the group, where efficiency formula is SAM into output divided by clock time. So kindly note that In the performance, it was on a standard time. In the place of on a standard time, here's clock time, and manpower has been also added because we are talking about the group. Then we have performance and efficiency. We talk about the utilization. Just now we talk about the utilization. Utilization is nothing, is basically the on standard time divided by clock time, and the whole will be multiplied by 100. So this is basically the utilization. So we discuss about the utilization, we discuss about the efficiency, we discuss about the clock time. So these are the basically the major formulas we are using. Now we will talk about after doing this terminologies, we talk about the concept of line balancing. The line balancing concept of line balancing is basically, line balancing concept is, the line is defined as a group of the operators. The moment we talk about the line balancing, two words are the line and balancing. If we talk about the line is defined as a group of the operators under the control of one production supervisor. Therefore, line balancing is concerned with the operations and work levels within a line. It is a function of the work study office to provide management with the information to help the efficient and productive running of the factory. And part of the information is the process known as line balancing. So to balance the line, to make sure that we have the group of the operators are in the line. So I will take the example, I just want to make it clear that we have the group of the operators. Some operation work content, maybe operation 1, operation 2, operation 3, operation 4, operation 5. We have the, suppose these are the operations are there. And we talk about the work content, or we are having the SAM, we talk about the SAM or work content. Suppose SAM for operation 1 is 0.5. SAM for operation 2 is 1.5. SAM for operation 3 is 1. SAM for operation 4 is 2. SAM for operation 5 is again 0.55. So we are having this 5 operations are there, and all the 5 operations the SAM is different. So now we have to balance the line. For balancing the line, we have to either we have the two extreme SAMs are there. One is 0.5 and another is 2, and other SAMs are in between. Other values are in between. So 0.5 and 2 SAMs are there, which is almost 4 times. So suppose we are keeping it in the balancing the line, and there is no constraint of the number of machines. We want to balance the line keeping 0.5 as my takt time. So 0.5, we have to allocate one operator for this particular operation. Here we have to allocate 3 operators. Here we have to allocate 2 operators. Here we have to allocate 4 operators. Here we have to allocate 8 operators. So we will have 1, 3, 4, 2, 6, 4, 10 and 11. So we have these particular operations, we have allocated the operators like this. So every operation, here we have the 1.5 is the work content. So we have allocated 3 operators. So ultimately for every operator the one content will be 0.5. Here one work content is there. So one is the SAM, so we are allocated 2 operators. Here 2 is the SAM, we are allocated 4 operators. Like that. So this is the way, this is the one way this is the way we can do the line balancing. Line balancing, we are also taking the concept of takt time. We talk about the pitch time also. We are taking these things into consideration, and then finally line balancing is done. So next concept is called the work in process or work in progress. That is also known as WIP. So WIP is in a garment factory. That's known as, this is basically work in process, or this is progress. So once we talk about the WIP, it's made up of all garments and their parts that are not completely finished. The parts which is inside the line, which is the inventories. Inventories are there. The example we can talk about, the bundle of the shirt that has everything attached but has not bottom hem. The shirt, the example is that we are having the shirt which is not completely finished. The bottom hem, one last operation is the bottom hem that is not done. So that is that known as a WIP. That will come under WIP. Suppose we have the 10 operations are there, and for the 10 operations we have allocated 10 operators, and then WIP of between the two operations there's a waiting of one bundle of 30 pieces. So we have the 10, so around 30 into 10 is 300 is my pieces, is my WIP. Because every workstation we have the one bundle, and we have the 10 workstations are having the 10 waiting bundles are there. So 10 into 30 is 300. The 300 pieces is basically the WIP. So WIP can be measured in units and unit of time. WIP, the moment we talk about the WIP, it can be measured in unit, and the unit can be measured in time. Basically the WIP is, suppose operation X. For example, we know that an operation X takes 0.5 minutes per unit to process, and we have 5 bundles of 12 units each. Then we have 30 minutes of WIP for that operation. That is, if we talk about that, so we have taken the 30 minutes of WIP is, we are having the 5 is nothing, is the 5, we are having the 5 into 12 into 0.5. So 5 into 12 into 0.5 will give the WIP for that. In some factory, we can find some operations that have days of inventory waiting to be processed. This is unacceptable for many reasons. So we should not keep the WIP for a longer period. WIP should be minimum, or we can say that it should be optimal. It should not be more, it should not be less. The advantage of controlling WIP, when WIP is controlled, there are two cost area that can be controlled: investment in the inventory and ability to reduce the production cycle. If the more WIP is there, the cycle of the production will also increase, and the investment will also be in the inventory. Investment is investing nothing, is the money what we have invested in raw materials. When we don't move the goods through the plant quickly, we are affecting cash flow directly. So that is blocking the whole cash flow if the more WIP is there in the line. So we have to manage the WIP, and we have to see that. The low WIP between the line, garments have less waiting time and complete the product cycle in the less time. If the large inventory is there in the time, the goods have processing are kept waiting longer and increase the overall throughput time. So this is the WIP. So we are having the low WIP. If the low WIP, basically low throughput time will be there, and low throughput time is basically permits a better coordination between sales and production, and it's quicker turnaround on which improves the cash flow. Then we talk about the low cycle time. Low cycle times gives manufacturers the ability to handle multiple styles. Clients are looking for manufacturer that can meet production schedule, that can handle multiple styles, and since they want to invest a little as possible in inventory, manufacturers that can handle low inventories, only factory that work with the lower WIP will be able to sell its services. So what happens nowadays, we have discussed that manufacturers or buyers are not giving the time, which is the time has been squeezed. The demand time has been squeezed. So earlier we are getting the 90 days or 120 days of the total lead time of the order. Now that has been decreased to 30 days of time or 45 days of the time. Even Jara is working on some other concepts, and they are doing this, that the quicker lead time. The lead time has been become very quick response time, the concept what Jara is following, that Inditex. So we have to manage the WIP in such a way that the turnaround time will be fast, and we will get the more orders, because buyer is looking for, buyer wants to give the order to the company which can be very fast, which can produce it very with the pace, we can have the lesser turnaround time. And so these are the basically the different WIP concepts are there. So which basically helps in the balancing, which helps in the production planning, which helps in the this making the getting the more orders. The next is the cost per SAM. Cost per SAM, the formula used to calculate the cost per SAM is garment cost into cost factor. Cost per SAM is basically garment SAM into cost factor. So cost per SAM is, we talk about the garment SAM. What is the SAM of the garment? And we will multiply the garment SAM into cost factor. This is basically the cost per SAM concept. So here, if you talk about the cost per SAM, cost factor is basically labor wages per day. So the cost factor is basically labor wages per day, and this labor wages per day, it will be divided further into the shift minute into efficiency. So it's basically further labor wages per day will be divided into shifts. Labor wages per day will be divided into shift minute into efficiency. So for a factory, shift time for 480 minutes, a daily operator wages is, suppose it's INR 200 rupees. So if the factory runs for 50% efficiency, the cost factor for the factory will be around 0.833. So today we have discussed about the different terms and different terminologies are there. We started discussion with, we have the discussion regarding the SAM, we have discussion regarding the clock time, we are discussing regarding the efficiency, we discuss about the performance, capacity study, WIP, line balancing, cost per SAM. These are the factors which is very important factor in apparel manufacturing, which is keep coming for the apparel manufacturing. We have discussed about the different type of the allowances also. What we for the calculation of the SAM, what are the allowances we are keeping into. We discuss about the rating factor also. And for each and every factor we have discussed about the formula, and the formula, how the formula has derived. With the example we understood that about that, how these formula has come up, what is the importance of the formula, what is the formula meant for. So these derivation we derive the formula, and then after we discuss about that. So hope things have been gone well, and these formula will be definitely important for apparel manufacturing. Let's begin to reviewing certain key terms used in apparel manufacturing. Production refers to output. Productivity is the ratio of output to input and is normally represented as productivity is equal to output divided by input. Input refers to all resources used in producing the output. Output refers to goods or services produced. Competitiveness of any location for running a garment manufacturing factory and or exporting units demand various requirements such as availability of labor, raw material, business friendly atmosphere, low wages, proximity to airport and seaport, and the cost of energy. As India is a vast country, the payment system is salary based, piece rate or incentive system. Indian exporters still pay more attention to quantity than quality, though much money is lost due to poor product quality every day. Indian exporters mostly prefer the piece rate system. Piece rate employees are highly motivated. They also have no obligation about their employer. When factories have no work, they don't have to pay operators. There are few challenges when company hires piece rate employees. Designing a fair rate is a major challenge. Most of the factories do not have a system to establish a fair rate or standard time. Generally, rates are decided by negotiations between the employee and employer. Until a rate is fixed, nobody works at their normal pace, and this results in company losing capacity. Let us now look at some more definitions. The time available to an operator to doing work during the day, it does not include lunch time. Time duration which an operator is unable to do some work due to factors which are not under his control, that is the time spent during the day during which no productive work is done. For example, power failure, machine breakdown or doing repairs for someone else. The time made available to operator for producing productive work, it can also be defined as the difference between clock time and off standard time. Thus, clock time is equal to on standard time plus off standard time. Off standard time is that time or the operator spends on unmeasured work or measured work that is classified as off standard. Example of off standard time are time that should be reported on labor cost control sheet, waiting for work, machine breakdown, unmeasured work operation not yet allocated, single minute value. Sampling, repairs not own, paid average for balancing, under retraining, indirect work such as covering for supervisor. Standard allowed minutes SAM also means time in minutes that is assigned to a specific operation after doing time study or using predetermined motion time systems. While single minute value SMV means the cost factor in cost per unit that is multiplied with standard allowed minutes to get the cost of the operation. Standard allowed minute or single minute value is generally calculated as observed time, what has done during the time study, plus rating, allowances, plus personal fatigue and delay allowances and synthetic time. When standard allowed minutes is used as an extension of single minute value, that is, it is the allocated time for a task rather than the measured time. Standard allowed minutes is equal to single minute value plus policy allowances. Allowances are added to the 100% time determined by the time study to give a standard allowed time. This permits the average operator to earn a satisfactory wage provided there are no abnormal delays. The operator applies herself to her work. Three categories are recognized as machine delay, personal and fatigue delay and incentive. Machine delay includes the following: thread change, bobbin changes on lockstick machine, cleaning and oiling of the machine, thread break caused by the operator, machine and thread, needle break, minor adjustment or changes in folders and attachments, and first 15 minutes of the machine delay. The machine delay factor is applied to total cycle time. This has the effect of giving a delay allowance on manipulating elements within the machine cycle, such as pickup garment. On an average, this does not present a problem since the percentage has been developed from actual experience. However, a job with an unusually high or low percentage of pure work in the cycle would merit a discretionary adjustment to the factor, and the engineer is expected to be alert for this. Some aspects of normal acquired personal time can be quantified, but fatigue itself cannot be measured. It is also impossible to separate personal and fatigue time because of their interrelations with one another. These allowances come into being through guesswork and trial based on general use. History and experience has proven these allowances to be reasonable, correct for a great many varying situations. Personal and fatigue allowance covers break periods, personal needs such as water and restroom, minor conversations, factors for losing pace due to getting tired. Efficiency is a measure of how well the section or factory is run. It is a measure of both the operator and the supervisor. Incorporates elements of operator performance and utilization into the single measure. When we make a capacity study on an operator, we are measuring the performance she should retain if she continues to work at same pace and use the same method, which can be as observed during the study. This means that at the end of the study, we can say that the operator has to capacity to be 120% performer or whatever performance level the study indicates. Capacity means the same as a capability. It means that the operator is capable of achieving the performance measured by the study. The rate corresponding to the average rate at which an operator will naturally work at a job, provided they know and adhere to the specified method, and provided they are motivated to apply themselves to their work. British standard provide the 0 to 100 scale for rating. Here 0 represents no work at all, 100 as a normal rate. We rate the job on this scale after observing the operator. A slow rate may be rated around 50 and a fast on 125 around. The concept of rating, known as US as grading, is fundamental in time study. The ability to rate effectively distinguishes a qualified time study practitioner from a novice. Rating is a process used by industrial engineering to compare the actual performance of the operator with his or her mental concept of normal performance. In order to rate, these must be a defined level of performance to compare with an average level. The rating is numerical value used to denote the rate of working. In order to rate, there must be a defined level of performance to compare with an average level. Time study professionals apply the concept of a standard operator. A standard operator is fully trained and motivated to perform a defined task, having a defined method, and is by definition average in terms of his and her work pace. Standard performance is achieved by a standard operator as long as working conditions are correct. Operator performance is primarily a measure of effectiveness of individual operator, sometimes referred as a pay performance, as it is usually measured within an incentive scheme. Operator utilization is a measure of how well the supervisor manages to keep the operators on standard. That is time on standard divided by the time attended, that is clock time into 100. Let us know how at some more definitions. Standard allowed minute, the time taken by a 100% normal operator to do a particular operation, including the personal, fatigue and delay allowances. The standard time produced by an operator in a particular day, it is calculated as standard allowed minute produced is equal to number of pieces produced into standard allowed minute for the operation. The work done by an operator during the time available to him in a day, it is represented as efficiency is equal to standard allowed minute produced divided by clock time multiplied by 100. A tool used to quantify the work content of an operator during the day. It is represented as performance. Performance is equal to standard allowed minute produced divided by on standard time into 100. A tool used to determine the time percentage during which the operator worked in a day. It is represented as utilization is equal to on standard time divided by clock time into 100. A line is defined as a group of operators under the control of one production supervisor. Therefore, line balancing is concerned with the operations and work level within a line. It is a function of work study office to provide management with information to help the efficient and productive running of the factory. The part of this information is the process known as line balancing. The method of line balancing will vary from factory to factory and depends on the type of garments manufactured. But in any instance, line balancing concerns itself with two distinct applications. They are setting up a line and running a line. Work in progress, also known as WIP, is made up of all garments and their parts that are not completely finished. For example, a bundle of shirts that has everything attached but has no bottom hem. We can measure work in progress in units or in units of time. For example, if you know what an operation X takes 0.5 minutes per minute to process and we have 5 bundles of 12 units each, then we have 30 minutes of WIP for that operation. That is 5 into 12 into 0.5. In some factory, you can find some operations that have days on inventory waiting for processed. This is unacceptable for many reasons. There are two cost areas that can be reduced if work in progress is controlled. That is investment in inventory. Second one is ability to reduce the production cycle. Inventory is money invested in raw materials. When we don't move the goods through the plant quickly, we are affecting cash flow directly. By having low inventory between operations, garments usually have less waiting time and go through the production cycle in less time. Large inventory levels between operations keeps goods waiting longer to be processed. This increases the overall throughput time. Low throughput time permits better coordination between sales and production. It also permits a quicker turnaround on which improves cash flow. Low cycle time gives manufacturers the ability to handle multiple styles. Clients are looking for manufacturers that can meet production schedule, that can handle multiple styles, and since they want to invest as little as possible in inventory. Manufacturers that can handle low inventory, only factory that work with low WIP with able to sell their services. Work in progress can be managed efficiently, managed in many ways. Production planning requires planning from marketing and sales to determine what will sell and what needs to be produced and when. This provides the basis of determine how many operators and machine will be needed. Trims are buttons, zippers, labels, thread, elastics and so on. A cut should enter the production line only when someone has verified that all the trims needed are available. An updated inventory of trims should be kept. A missing label could halt 12,000 unit which is already cut. Holding the 12,000 unit in inventory is not acceptable and could lead to another problem. Careful consideration should be given to loading the production lines. If more products than can be processed are fed into the line, you will overload the line with work what will just sit stagnant. Even if you load the line based on its capacity, you might find the inventory accumulating due to an unbalanced production. Absenteeism and turnover can greatly affect the line's balance. A change in style and bad cutting are other two factors that can put a line off balance. To keep a line balanced, you need informations on the inventory labels. To help regain balance is an unbalanced situation, you can use utility operators, operator transfers and overtime. In order to keep control over the work in progress and to keep the cycle time low, you need to have cuts go as close as first in, first out as possible. For this reason, strict control must be placed on the tracking the cuts as they flow through the production floor. The formula used to calculate cost per standard allowed minute is garment standard allowed minutes into cost factor, where the cost factor is per minute labor cost to the factory at factory average efficiency. Or simply, instead of cost factor, you can multiply garment standard allowed minute by average labor salary per minute, which represents cost factor calculated at 100% efficiency. Whatever method you use must be clear to everyone. Persons who see the report within the factory, cost per standard allowed minute is fixed for a style. Cost factor is equal to labor wages per day divided by shift minutes into efficiency. For example, for a factory shift time of 480 minutes, a daily operator wages is rupees 200 rupee. So, if the factory run at 50% efficiency, the cost factor for the factory will be 0.833. In this unit, you have reviewed key terms, definitions and formulas used in apparel manufacturing industry, including production and productivity, line balancing, WIP management, the concept of an on standard, off standard and clock time, SAM and SMVs, allowances, efficiency, capacity study, lost time, rating, labor and wages as well as cost per minute. Thank you very much.